Hello?
Bueno.
Hello? Alright, so now we have new additions to this class. We have Mr. Plushkin. And alright, so okay, so we're gonna do this. So find a definite integral using substitution. Now, let's take a look at it and say, hey, what is nasty?
The bottom.
The bottom. Good. That's a good start. Remember what I said. Okay, what did I say whenever I'm using chain rule? Ah, crap. You sub.
Crap.
Chain rule, right?
What?
Chain rule, right?
Yes.
If I was going to take the derivative, I would have to use chain rule for it. Yes? Okay, so what is the piece that's going to mess me up here?
The radical.
The 4 minus x squared, right?
Yes.
Okay, good. That's going to be 4 minus x squared. So I'm going to say that u is 4 minus x squared. Du is going to be it's going to be what? Negative 2x dx. Does that help me out? Okay, remember, whenever we're doing these are like a puzzle. You have to see how it fits. Okay, so if I were to do that, I would still end up with an x, wouldn't I? That one's not going to work out very well, right? Because when I do this, I can't substitute this. What would happen is I would end up like this. And I would be putting in another x, wouldn't I?
Yeah.
So if I put in another x, then that means that I, right here,
Yeah, you should, yes.
I would have to take the square root, right? And then there, whenever I take a square root, there's always going to be a plus or minus, isn't there? Okay, so if I were to do that, I would end up with a, let's see, it'd be u minus 4 equals negative x squared, so it's going to be divided by the negative 1, so it's 4 already minus u equals x. First hour already.
Yeah, x squared.
Yeah, hold on. Yesterday it started during the second hour. I'm sorry, can't do anything about it. This thing gets so loud. Wait till it ramps up a little bit more.
I wonder what the YouTube subtitles are going to say about the factory.
I don't know. Okay, so right there, that's really not going to help me, right? Is that going to help me there? No, because x squared is going to be equal to this. And if I took the square root, it would be x equals plus or minus square root of 4 minus, that's a 4 minus u, right?
Oh, right. Yeah, no,
That's not going to help because I'm now going to have a plus or minus in there. So this piece is not going to fit very well. Okay. So now knowing it's not going to fit very well, I really don't want to use that. All right, so what else could I try and do? Anyone remember those cards I gave you? Yes?
Oh my god, wait, isn't that the sign one?
The sign one?
Yeah, the sign one.
Yep. So this is going to be
It is, isn't it?
Yes, it is. All right, so what are my values though? So with the sine one, I am going to, I gotta take out a value. Okay, because there's a problem. I have to have 1, right? It's gotta be 1 minus. Say yes.
Yes.
It's gotta be 1 minus. So for my sine, it's supposed to look like 1 minus. So from your card, which is going to be arc sine x plus c, right? Yes? Okay, so that's your card, but the problem is, does it look like that? It doesn't look like that, does it? So I have to have the 1 minus. So now I have to take care of that. So how can I deal with that 4? I'm already saying F word.
Like
Factor.
separate the.
Factor, yes. We're gonna factor out. So if I factor out the 4, so I know I gotta use this. So let's take a look and. So if I factor out a 4, I'm gonna be left with, let me see, square root of 4 parentheses 1 minus, what's that gonna be? X squared. I'm dividing by 4 though, right? Because I have to factor it out. Over 4. Right? Because I have to have a 1 here. This thing right here is just going to end up being a square. And I'm going to figure out what that's going to be here in a second. So now, this is basically just saying, algebra-wise, square root of 4 times the square root of 1 minus. Now, I got to clean that up. I got to have a square on top and bottom because I need to have my value right there, my value to be something squared. I can't just have the top squared. I got to have the top and the bottom. So how would I rewrite that? X over 2 close square. Now can I do my arc sine? Now it looks better. Now it looks better. So from here, actually, there. Okay, it'll just make my brain itch. All right. So from there, that means that I'm gonna have a 1/2 in front of this, right? So if I do that correctly, it's gonna become 1/2 integral of 1 over square root of 1 minus x over 2 squared dx. All right, take the integral, and we already know what it's supposed to be, right? Because I gave you these things a while ago. So from here, it's the arc sine, but what am I going to put there for x?
X over 2.
X over 2, very good. So I'm going to put x over 2. So now that's going to be 1/2 arc sine of x over 2 plus c.
We didn't use substitution here, right?
Right, we did not?
Yeah, but it says finding integrals using substitution. But we failed.
No, we didn't.
We failed. We didn't. It says using substitution, but we didn't use.
Okay, so now we're substituting right here because I've told you guys already what this is. So it's kind of like, hey, do you have to every time when I say, what is the integral of, let's say, tangent? Didn't we do that the other day?
Yeah.
We did do that the other day. Let me back it up. Here it is. So every single time when I say, hey, what's the integral of tangent? Do you have to do that every time? No. I'm trying to show you that you can go from here straight to here as long as you know those identities that I told you. Cut out all the work, all the middleman, you have the identity for it. So an identity means we use this as my answer. Make sense? Where am I at? Am I here? Okay. Alright, so from there we have that factored out. Now can I erase this and do B? Okay, let's erase it and do B. Is this another identity? What's this one? Arctan. But what's it gotta look like? Okay, so let's see. It's supposed to be arctan, right? So integral of something over. What's the format for arctan? 1 plus x squared. And this is like this, right? Equals arctan of x plus c. Again, what is the issue I came up with? Okay, so factor out the 9, right? So factor out 9. So now I'm going to have, let's see, so it's going to turn into, I'll come over here to do this one. All right, 1 over 9 quantity 1 plus 4x squared over 9, right? Change this little piece right here. 2/3, right? So that's going to be the integral of, let's see, 1 over 9, right? That is my coefficient. My coefficient I could factor out in front, and then it's going to turn into 1 over 1 plus 2x over 3 squared dx. Super easy. Okay, you have to be able to identify these things right away. They're like, oh hey, look at that. All right, so now from here, this is going to turn into 1/9 arctan of 2. I said 2 and I still wrote 3. So 2x over 3 plus c. Yeah? Good? Okay, so these are 5.5. They're in the back shelf. Okay. All right, find a definite integral using substitution. 2 approaches can be used to find definite integral using substitution. Method 1, find the related indefinite integral using substitution and then use the fundamental theory of calculus, breaking it up. Method 2, find the definite integral directly by making a substitution in the integrand and using substitution change the limits of the integration. Okay, so we can plug it back in to figure out and just change the limits. So it'll make more sense here in a minute. All right, see that? Definite integral means it has bounds, right? Yes, okay, good. So if it has bounds, should I have numbers for my answers? Yes, because I'm basically looking for the area under the curve or whatever application this is going with, right? All right, what do I want to try to use? Remember chain rule. So what do I want to try to do? So it's going to be a puzzle and it's got to fit. 4 minus x squared. 4 minus x squared, right? Because that would be the chain, right? Okay. What about my du? Negative 2x dx. Okay. Ooh, is this one going to work out nice? Yeah, that's a nice. All right, so times negative 1 over 2. Oh, man, that's ugly. All right, try this again. So negative 1 over 2. Okay. All right, so now when I do this, so let's see, my x dx is going to be replaced with negative 1/2 du. So I'm replacing that, so now my math is going to look like this. So it's going to be u to the what? Say 1/2. Okay, so 1/2 u to the 1/2 times negative 1 over 2 du, and right here my integral. Okay, so let's see what this is going to be. My lower bound. If these are for my x's, where should I plug it into my substitution? Say x. Very good. Okay, so 0. Let's look. 4 minus 0 squared gives me 4. So my new bound is 4. Okay, so how about 2? It's going to be 4 minus 2 squared, which is... Okay, so that's going to become 0, isn't it? Okay, so now, what's wrong here? Okay, so now they're out of order, right? So how do I fix that? Minus in front, right? And then fix it. So now it's going to turn into the negative integral from 0 to 4 of my negative 1/2 u. Yes, because the lower bound is on top here. That's a fundamental theory of calculus right there. So the lower bound is on top, and I could switch it from here to here by making this opposite. This was on the test also, where we had a couple of these. All right, so we have that, and then it's going to be 1/2 du. So that's going to work out nice and pretty. So now I'm going to factor out the negative 1/2, right? Say Jess. Yeah. Okay, so factoring out the negative 1/2 makes this whole thing positive, right? Yeah. So it's going to be integral 1/2 of u to the 1/2 du. All right, don't forget we're adding the value of 1. So in this case, I'm adding 2 over 2, right?
Yeah.
So this is going to turn into u. Hold on. Let me fix this real quick. Okay, so there's 1/2 out front, and now it's going to be u to the 3 over 2. Okay, so now reciprocal that, so it's going to be 2 over 3. And so now, what do I add? So this is no longer this is going to be a definite integral. So that means I'm going to have bounds. So that means right here goes from 0 to 4, right? I no longer have that plus c. Yes. Now, because I did it like this, and I substituted my bounds also, that means I don't have to put it back. I don't have to substitute it back in. And this makes a whole lot of sense, and it makes a whole lot of things easier, because later on, when you have to do multiple substitutions, trust me, my Cal 2 class, I was so salty, we had to do 3 subs. So I did U, S, and T, and I had to change the bounds for every single one. So it was a nightmare. It really was. So anyway, but still, let's go ahead. Top minus bottom. So it's going to be 4. What's square root of 4? Come on, square root of 4.
16.
Okay, so square root of 4 is 2. 2 to the third power is 8 times 2.
16.
Very good. So I'm going to have 16 over 3 minus my lower bound, right? Okay, 0. Square root of 0 is 0 to the third times 2/3. Okay. So my answer should come out to be
16 over 6.
16 over 6, or can I reduce that?
Yes.
8 over 3. Does that make more sense? Yes.
So if you change the bounds to be in terms of, then you don't have to substitute the x back in, like you
No.
said as u?
Yeah, you can leave it as U bounds now.
Okay, cool.
These are now U bounds. If I did not substitute my bounds, I would have to put my U back in. I would put my 4 minus x squared back into my function. And then I would have used my x bounds.
But either way is like.
Either way is correct, but in this case it makes math a whole lot easier. Because, here, let me show you 4 examples. So if I did not do that, insert page after. So what was my function? It was,
The original
so from the U, so it's 1/2, right?
u
I gotta go back. All right, so it was negative 1/2, right? Yes, negative 1/2. Because I'm not going to do the U bounds. I'll show you why. I'll use the X bounds. So negative 1/2 integral of, okay, so from 0 to 2, these are the X bounds, and this is U to the 1/2 du, right? Okay, so it's going to be negative 1/2 bracket, that would be U to the 3/2, right? And over 2/3 from 0 to 2. Put my U back in, so negative 1/2, and so that's going to be 2 parentheses 4 minus x squared, right?
yeah, 4 minus x squared.
Okay. To the 3/2 over 3 from 0 to 2.
That's a lot more complicated.
Yeah, more complicated, but I'm showing you that it still works. It's still going to work. So now let's see. So that's going to be, my top bound is going to be, let's see, 4 minus 4 is 0 to the power, so it's going to be 0. So negative 1/2 bracket 0 minus my lower bound, which is going to give me, let's see, 0 there. So that's going to give me 0, 4, square root, 4 is 2, third 8, times 2, 16 over 3, minus 16 over 3. So this is going to give me negative, negative is a positive. It still works. But is it a little bit more work?
Yeah.
Yeah, just a little bit more work. So you subbing your bounds helps out a lot too. All right, so we will finish the rest of this come tomorrow.
Tomorrow?
Tomorrow.
What do you mean after spring break?
No, tomorrow. I gave you guys, tomorrow's still school, right?
30 minutes.
Yeah, I know you're probably not going to show up. So, I'm still going to teach.